Welcome to this explainer. Today, we're jumping right into the fascinating intersection of environmental science, human policy, and resource management. We're going to unpack a truly core concept, the idea that environmental literacy is, well, it's actually civic literacy. You literally cannot separate the two. Because think about it. When we understand how our ecosystems function, we understand exactly how our society survives. To wrap our heads around our complex environmental reality, we really have to start with this incredibly simple yet profound truth from Dr. Seuss's The Lorax. It absolutely captures the urgency of resource management. Environmental stewardship, it isn't a passive spectator sport. It requires active, informed participation, because every single choice we make ripples right through the very systems that are keeping us alive. Okay, so here's our roadmap for today. First, systems in civic ecology. Then, the Colorado River crisis. 3. Rethinking agriculture. 4. Global restoration. 5. The pollution pipeline. And finally, who owns the water? Let's dive in. Section 1. Systems and civic ecology, the foundation of life. We so often think of nature as just like beautiful scenery, right? But it's really an invisible factory. Ecosystem services are the tangible, real-world benefits that ecosystems provide to us humans. We're talking about things like wetlands filtering our drinking water, bees pollinating the actual food we eat, and forests pulling carbon right out of the atmosphere. Without this underlying biology doing the heavy lifting, human civilization is, quite literally, impossible. Moving on to Section 2, the Colorado River crisis, a legal and ecological deficit. Let's look at the Colorado River. It's one of the most highly engineered and, honestly, fought-over rivers in human history. It supplies 40 million people across 7 U.S. states and Mexico. But here's the catch. The foundational law dividing the river, the 1922 Colorado River Compact, was based on a massive miscalculation. Negotiators measured the river during an unusually wet period and promised 15 million acre-feet of water to the surrounding states. But the actual long-term average flow? It's closer to 12 or 13 million. So before a single drop was even drawn, they created an ongoing structural deficit. They promise more water than nature actually provides. Combine that with a permanent drying trend, what scientists are calling aridification, and the math just simply doesn't work anymore. Just look at this massive 75% slice of the pie. That water goes entirely to agriculture. We're talking about watering thirsty crops like alfalfa, cotton, and citrus right in the middle of the desert. Meanwhile, highly populated municipalities take up just under a fifth. But look at that tiny little sliver at the bottom, environmental flows, meaning the water actually left in the river to keep the ecosystem alive, receives less than 1%. In fact, it's gotten so bad that the river itself doesn't even regularly reach the sea anymore. Which brings us to Section 3, Rethinking Agriculture, Hydroponics, and Soil Health. That number right there is an absolute game changer, 95%. That represents the staggering amount of water saved by well-designed hydroponic systems when you compare them to traditional field irrigation for crops like lettuce. Hydroponics, if you're not familiar, grows plants in nutrient-rich water without any soil. Because it's an enclosed, recirculating system, there's zero runoff and no evaporation from bare dirt. If arid regions transitioned more of their leafy green production to hydroponics, we could save tens of thousands of acre-feet of water every single year. Now, sure, it requires massive upfront investments and a lot of electricity, but the water efficiency, it's completely undeniable. But hey, we can't just abandon soil entirely. In fact, we need to start treating topsoil as a living ecosystem, rather than just some static medium meant to hold plant roots. By using ancient regenerative techniques, things like crop rotation and cover cropping, farmers can actually reduce their need for synthetic fertilizers by up to 50%. And even more importantly for our water crisis, healthy soil, loaded with rich organic matter, acts like a giant sponge. Studies consistently show that farms using cover crops see higher yields even during drought years. Why? Because their improved soil actually holds way more water. Section 4. Global Restoration, the Great Green Wall. Right now, we're focusing on the Sahel region in Africa, which is this semi-arid band right below the expanding Sahara Desert. That 18 million, that is the number of hectares of degraded land already restored by the Great Green Wall Project. It's literally the most ambitious land restoration project in human history, stretching 8,000 kilometers right across Africa. And what's truly amazing here is that much of this success isn't coming from, high-tech satellite interventions. No, it's coming from traditional, community-driven methods that capture rare monsoon rains and regenerate the earth.
The technique driving a massive part of this transformation is called farmer-managed natural regeneration, or FMNR. See, for decades, outsiders tried planting brand new trees in the Sahel, and the seedlings just died in the heat. But local farmers and scientists realized something incredible. The root systems of ancient felled trees were actually still alive underground. So they shifted to a really simple four-step process. 1. Stop cutting the small shoots that pop up like weeds. 2. Select a few strong ones. 3. Protect them from grazing animals. And 4. Just let them grow. This one simple change in behavior has led to millions of trees regenerating on millions of hectares of farmland, and they did it without planting a single new seed. How cool is that?
Section 5. The pollution pipeline, what we put in comes back. It's a hard truth, but what we put into the water always comes back to us. We are currently facing 3 major invisible crises. First, we have microplastics. They're breaking down in our oceans to the point where they are literally now found in human blood and placentas. Then we have nitrates and phosphorus. This is perfectly legal agricultural runoff from the Midwest that washes down the Mississippi River, creating a dead zone the size of New Jersey in the Gulf of Mexico and suffocating marine life. And finally, PFAS, or forever chemicals. These create invisible, highly persistent groundwater contamination that just slowly spreads across the country. It really shows us how geographically distant actions create massive systemic health and ecological impacts. But look, we absolutely cannot fall into despair here, because ecological recovery is entirely possible. Just check this out. Back in 1969, the Cuyahoga River in Ohio was so polluted it literally caught on fire. Today, it supports 44 different species of fish, and the Chesapeake Bay has reduced its nitrogen pollution by 25% since the 1980s. These recoveries, they didn't just happen by accident. They required decades of fierce political will, strict legal enforcement, and passionate civic action. When we actually decide to clean up our act, the ecosystems respond. And that brings us to Section 6, Who Owns the Water? The capstone debate. So, circling back to the Colorado River, every single stakeholder here has a deeply valid claim. The farmers? Well, they hold the oldest legal rights, and they literally grow the food that feeds the nation. Municipalities like Phoenix and Tucson have invested billions in world-class water recycling, and they drive the economy. Tribal nations, like the Navajo, hold senior federal reserved rights, but were historically excluded from the original compacts. I mean, many families still lack running water today. States like California and Nevada have massive conservation investments and a lot of political power. And then you have environmental advocates and Mexico standing up for international treaties to save the dying river delta ecosystem. Every single group's claim directly conflicts with the survival of the others, all in a system that simply doesn't have enough water. So I'm going to leave you with this final thought to ponder. We have a shrinking resource, competing human laws, and the unforgiving laws of nature. If the river is entirely used up, every single stakeholder we just talked about stands to lose everything. So at what point does cooperation become not just some ethical ideal, but a matter of purely pragmatic self-interest? When does working together become our literally only path forward? Think about that as you consider your own role in the civic ecology of our planet. Thank you so much for joining me for this explainer.